எலக்ட்ரிசிட்டி சாப்டரோடைய நியூமரிக்கல்ஸ் பார்ட் ஓரியன்டாக என்னென்ன எக்ஸாம்ஸ் கீ பாயிண்ட்ஸ் உங்களுக்கு தேவைப்படுங்கிறத தான் இன்றைக்கி வீடியோவில் பார்க்க போகிறோம். நத்திங் வெரி இம்பார்ட்டன்ட். கண்டிப்பாக உங்களுக்கு ரெசிஸ்டர் ஓரியன்டாக கொஷின்ஸ் கண்டிப்பாக வரும். மினிமைஸ் த ரெசிஸ்டர்ஸ் வேல்யூ அண்ட் ஃபைண்ட் த ரெசிஸ்டர்ஸ் இன் சீரீஸ், ரெசிஸ்டர்ஸ் இன் parallel, as well as the ohms law யூஸ் பண்ணி 1 mark questions வருமா? கண்டிப்பாக வரும். ஸோ பெட்டர் கோ த்ரூ ஆல் த ஃபார்முலாஸ். எலக்ட்ரிசிட்டி ஓரியன்டாக உங்களுக்கு எது ஃபார்முலாஸ் இன்ன வரைக்கும் படிச்சிருக்கீங்களோ எல்லாத்தையும் ஞாபகம் வச்சுக்கோங்க. ஸோ ஓம்ஸ் லா ரிலேட்டட் கொஷின், ரெசிஸ்டர்ஸ் இன் சீரீஸ், ரெசிஸ்டர்ஸ் இன் parallel, அண்ட் ஹவு டு ஃபைண்ட் த பவர் வேல்யூ இன் ஈச் கேஸ். பவரோட வேல்யூஸும் கண்டிப்பாக எப்படி கண்டுபிடிக்கிறது. அதே மாதிரி கண்டக்டிவிட்டி எதில் அதிகம், எந்த மெட்டீரியல்ஸ்க்கு அதிகம், பேஸ்ட் ஆன் த கிளாசிஃபிகேஷன் ஆஃப் த மெட்டீரியல்ஸ் ஆல்சோ, கண்டக்டர், செமிகண்டக்டர் அண்ட் இன்சுலேட்டர். So how it is varying, what is the conductivity of the materials, how it is varying, as well as the resistivity, and how both are related. In conductivity and resistivity, how they are related, இதனோட ரிலேஷன் வச்சு கிராஃபிக்கல் ரெப்ரசன்டேஷன்ஸ் கொடுத்தோ இல்லை மெட்டீரியல்ஸ் கொஞ்சம் கொடுத்துட்டு அதனுடைய ரெசிஸ்டிவிட்டி கண்டக்டிவிட்டி கொடுத்துட்டு அதனுடைய கிளாசிஃபிகேஷன்ஸோ they can check in any manner. பட் கண்டிப்பாக அந்த இது ரிலேட்டடாக நியூமெரிக்கல்ஸ் பார்ட் இருக்குமா? இருக்கும். பவர் கன்சப்ஷன்ஸ் ரிலேட்டடாகவும் அதில் ரேட் கொடுத்து ஹவு மச் இட் இஸ் காஸ்ட் வைஸ் எப்படி கல்குலேட் பண்ணுறதுங்கிற மாதிரியும். ஸோ தே மே ஆஸ்க் எனி டைப் ஆஃப் கொஷின்ஸ் ரிலேட்டட் டு த எலக்ட்ரிசிட்டி இன் தீஸ் பார்ட்ஸ், ரெசிஸ்டன்ஸ் ஓரியன்டட், கண்டக்டிவிட்டி and types of materials, how it is classified. So these things and all, how it is connected, resistors in series, resistors in parallel, and when it comes the combination of, that is combination of both series and parallel, adanode total resistance, how to find the total resistance. So these parts and all very very important question. So I'll give you an overview about the same thing only here. Let's see. So what is the first part? We should know the formula. When the resistors are connected in series, how to find the total resistance, and when they are connected in parallel, how to find the total resistance. So let's see. When the resistors are connected in series, resistance in series, total resistance when it is connected in series, for example, I am taking as it is there in the book, if I connect 3 resistors in series, which is R1, R2 and R3, then we apply the battery, means source to the circuit, plus minus V is the potential which is applied externally. Then due to the applied potential, current starts flowing into the conductor. The current is taken as I. Then what is the total value? V is the applied voltage, total voltage. I is the total current in the circuit. And 3 resistors which are connected in series, end to end connection. One resistor's end point, another end starting point connect ஆயிருக்கும்போது they connected it in series. When it is connected in series, how to find the total resistance? So the series resistance value we can find by adding the total amount of the resistors which is present in the circuit. So series R resistance Rs can be given as adding R1, R2 and R3 will give you the total resistance of the circuits. Whenever the resistors are connected in series, we have to add the individual resistors given. So Rs is equivalent to R1 plus R2 plus R3, which gives you the total resistance of the circuit. So if you found the total resistance, the circuit will get replaced in such a way that Rs connected with the battery, you have to add the individual resistance, find the total resistance Rs, then mark I, V. So we can minimize the circuit given into this manner. The total resistance of the circuit, by adding the individual resistance, we will get Rs. So Rs is equivalent to R1 plus R2 plus R3. Then any one of the value they will give you. It is not that both the values are unknown to you. They will give you either an I value or V value. For example, in this case, if R here is 1 ohm and this is 2 ohm and this is 3 ohm and total applied potential is 50 volt, they are asking find I. What is the I value? You have to find out the I value means nothing. You have to add the individual resistance 1 plus 2 plus 3, that give you 6 ohm is the Rs. So what is the total resistance, series resistance in the circuit? It is 6 ohm and the applied potential is 50 volt. So what is I? How to find the I value in this case? So I is nothing but according to the Ohm's law, what is the value? V equivalent to IR. I is equivalent to V divided by R, and V is the applied potential. Total output, to find the output, what is the input? Input is nothing but the source which is applied here. The source, what is applied, what is the value? That is V is equivalent to 50 voltage. So 50 voltage is the applied voltage, and 3 resistors which are connected is R1 and R2 and R3. Find the total resistance. Go for the applied voltage. Applied voltage is 50 voltage. So I is equivalent to V divided by RS. Don't simply put R. As 3 resistors are connected in series, we have to put 3 resistance in series. The combinations mean the total resistance. So RS is equivalent to 50 ohm, 6 ohm. So what is I value? 50 divided by 6. So what is the value? 50 divided by 6? It will be around 8.3 ampere. What is the current in the circuit? 8.3 ampere. So this is very easy method. Find the total resistance. They have given you the voltage value and how it is related. I, they are asking you the I value and RS value. Once you know, V value you know, we can substitute. I is equivalent to V by RS. V is given 50 and RS we found, which is the total number of the resistance, adding all the individual resistance, 3 resistors. So add the 3 values, which is 6 ohm. So 50 divided by 6, which is nothing but around 8.3 ampere. Okay. So this is when the resistors are connected in series, how to find the total current in the circuit. In the same case, if they have given the current value and they are asking you to find the voltage, nothing much. You have to substitute the RS and multiply the I value. You will be able to get what is voltage applied. Any one of the parameter they will give you. It is not that both they will not give you. Any one of the value they will give you, so that easily you can find out the unknown. In the same case, in the same circuit, if they are asking the power dissipation, power consumed by each resistor, that means it consumes P1, it consumes P2, resistor R2 consumes P2, resistor R3 consumes P3. So what is the power consumption or power dissipated from each resistor if they are asking? Power value, we know the V value and I value now, and in series the I value remains same. Go for the thing which remains same. Series, what is the key point? Series, current I remains same. Whenever we go for series connection, current I remains same. So throughout the circuit, which value remains same? The I value will remain same. By using the I value, easily just by multiplying the R, will be able to get, as we have 3 equations for power, P is equivalent to V into I. So here, and one more formula, V square divided by R, and another formula, I square into R. And in this case, you can use the one which is very well known, I square into R. Why I am selecting this formula? Because the current voltage will be keep on varying. So leave the equation which is related with voltage. Whichever is the varying parameter, you leave that equations. V here, this equation holds V, leave it. This equation holds V, leave it. And this is the one which is having a parameter which remains same throughout the circuit. So take this one. So P is equivalent to I square into R, because I remains same across through all the resistors. So take I square into R. So how to find out the P1, P2, P3? As we have 3 resistors which are connected in series, we can find out by substituting P1 is equivalent to I square into R1, and P2 is equivalent to I square into R2, and P3 is equivalent to I square into R3. What is the unit for power? Watts. Okay. So P1 is equivalent to, if I got 8.3 the whole square into R1, which is nothing but 1 ohm, and 8.3 the whole square into R2 value, which is 2 ohm, 8.3 into whole square into 3. So similar. Very easy to find out the power consumptions. So it is directly proportional to the resistance. Whichever is having a high resistance will consume the lot of power, and which is having less value will consume less power. 8.3 square if you got, Easily just multiply with the resistors value, you will be able to get the power dissipation from each resistor, which is P1, P2 and P3. So this is very easy method when the resistors are connected in series. Hope you understand the things. So resistors, whenever it is connected in series, just find out the equivalent resistance, find out the unknown parameter. It may be of voltage or current. One value they will give you, another one you have to find out. So find the unknown parameter, then substitute whatever they are asking. If they ask up to the current or voltage value, you can stop up to that. Or if they are asking the power, you go to the another formula to find out the power value. If it is connected in parallel, the same procedure, same thing we have to follow, but only one difference is when the resistors are connected in parallel. What is the next one? In parallel, when they are asking, what is the main change? The total resistance varies. If three resistors are connected in parallel, means starting of the one resistor, ending of the one resistor will remain same for all the other resistors too. If I am taking this is R1 starting ending, R2 starting ending also same point, R3 starting ending also same point. Voltage remains same. Which remains same in this circuit? Voltage value remains same, plus minus V, and the current in the circuit is I. Here current value will get divided, means through R1 I1, through R2 I2, through R3 I3. Currents get divided, voltage remains same. In series, current value remains same, voltage gets divided. So how to find the total resistance? Rp, 1 by Rp is equivalent to 1 by R1 plus 1 by R2 plus 1 by R3. So whatever the values given to you, R1, R2, R3, just substitute, and you may be able, you have to take the reciprocal to find the Rp. Find the parallel resistance. Then similarly find the unknown voltage or current by using Ohm's law, then power value also. In this case we can use which remains same? Voltage remains same. So P value you can find by using V square divided by R. So always take the equation which remains same, which parameter remains same. In series current remains same, so I square into R. In parallel voltage remains same, so take P is equivalent to V square by R. So this type of question, series and parallel, you will get a question from electricity for sure. Do it slowly, don't take any like in emergency, don't do all these things. So suddenly this may be the answer, this may be the answer. Don't go for like that. Slowly do the things, find out each and every answer carefully, then substitute the values, check whether you are getting the same answers, similar answers, at least approximately the same values, whether you are getting or not. Just kindly check everything, then proceed it further. All the best, do well, thank you.